Welcome, my fabulous chemistry students. Video number 2 for Unit 3 periodic table. We are going to dig a little bit deeper, slow steps into the periodic table and check out how they're arranged. Today we're going to focus on what a group is and what a row is. Okay. Does the periodic table work like a map? In some ways, very much it does. Which row and which group I am could act kind of like a coordinate system, but of course in chemistry it's going to kind of more tell me how many energy levels do I have and how many valence electrons do I have. But it's a lot of information I need to know. A little carrot, ready? If you did not yet sign up for Text Alert, as I asked for in the first video, you sign up for it, I will be able to check my Remind Me app, see your name, and give you a STEM buck. Okay, so remind me when you get into class to check if you signed up. STEM buck is on the line, free of charge. All right, so the arrangement of the periodic table. Let's start first going across. Okay, so these horizontal rows are called periods as I go from left to right. And you can see here that this is the fourth period, period number 4 in our reference table. And as we go across, here are the elements. Okay. So it asks us to, okay, well, element name. Element name for K is phosphorus. No, it's not. It's potassium. Potassium. There you go. And it's in group number 1. Electron configuration of phosphorus. 2, 8, 8, 1. Lewis dot diagram. I have a K, 1 electron. All right, Ca is calcium. Calcium is a group 2 atom. We do groups next, by the way. Its electron configuration is 2, 8, 8, 2. Ca, 2. Okay, good. We're getting the hang of this. I'm going to leave a few of these for you guys to do yourself with your periodic table. I'm going to focus on the electron configurations and the Lewis dots for the rest of them. How's that sound? Okay. Ga, we're going to move all the way over. So this is a group 3. And it is 2, 8, 8, 3. And that's going to be Ga, 1, 2, 3. Ge is group 4. You're going to see that here on this where it says groups, it's going to say 3, and on ours it actually says 13, and then it says 14. That's because you'll see that the groups change for those transition metals that we're going to learn about, and it makes selenium 3. But we're going to say group 3 is this whole boron, aluminum, gallium group. Okay, 2, 8, 8, 4. That has 4 valence electrons, so it's going to look 1, 2, 3, 4 like that. Remember, first two together, then one at a time around the bus. I'm going to jump to 18 too, by the way. That's where this happens here. So, As is group 5, and on our periodic table it says 15. That's going to be 2, 8, 18 with a 5. You guys starting to notice a trend here? As, 5 valence electrons, 1, 2, one at a time around the bus. Looks something like that. You guys noticing the trend? See what's happening right here? As I go across the group, I'm adding 1 valence electron. So, an octet, we heard this before, an octet is a full valence shell of 8 electrons. That is there's always an exception in chemistry, right? Period 1 elements only have 2 electrons, so hydrogen and helium can't hold more than 2 in that s orbital. So let's remember 8 is great. Onto the groups, that's those vertical columns, and we actually just talked about them a little bit when we were filling out that last chart. That's how we go up and down here. You see the red and the orange and the colors. And this is where there is that discrepancy, where we have it 1, 2, and then our periodic table says that's 13, 14, 15. Well, that's really 4, or I'm sorry, 3, 4, 5 as far as the groups. I'm going to pretty much accept either one of those, but I usually go by the single letters, or the single numbers, I'm sorry, because that's how I learned it. And these things change over time. This periodic table is probably going to come out next year and be a new one altogether, especially if Monaco finds a new element, which I'm really kind of excited that he tries to do that. All right, so we're going to do here the first group. So that's group number 1. And I see hydrogen starts first, hydrogen. Electron configuration, 1, Lewis dot 1. All right, below hydrogen I have lithium. Electron configuration, 2-1, lithium, 1 valence electron. All right, I'm doing one more sodium. You'll be able to figure this out. Ready? Sodium, Na, is 2-8-1. Sodium has 1 valence electron. We're starting to see the trend here. 1 valence electron all the way down the row. In my Lewis dots, all look almost exactly the same. 1 valence electron. This means that these particular atoms are all going to react very similarly because they all have that 1 valence electron. And if you remember way back when we decided which element we were going to be, we found out that these guys all react very, very violently with water. That's one of their main properties. Yeah, that's what we're going to call it, properties. All right, practice. Oh, look at this. You don't have multiple choice practice. Not anymore. You got to go back in and watch these videos and start to figure out, oh, look, some of these practice questions, you need the first video, Henry Mosley. It's in there. So you guys got to do some of these practice problems. They're going to be straight out of the videos, I promise. You watch the videos and take your notes. You'll be able to do these just fine, guys. Again, don't forget to sign up. You can also do in practice packet page 14, 25, and 29 now. And you've now unlocked a little bit more of the hidden information that we have in the periodic table and the names of groups and rows. See you guys tomorrow in class.